Fantastic. Good morning, everyone. After that build-up, I feel like you're set up to be disappointed, but I shall do my best. I shall do my best. And I got really excited thinking about those old days with the swords and the hit points and stuff like that. It's fantastic to be back at the SF Jazz Center. I don't think probably most of you know this, but so this is the GraphTour, which you can kind of hear it in the name. And Lance mentioned this. We bring this around the world, and we visit multiple cities. It's a full day event, and then once per year we have this conference that we call Graph Connect, which is multi-track, big deal. And the first one was in 2012, but a couple of years after that, we actually had Graph Connect here in San Francisco at the SF Jazz Center. And we had, I don't even remember, maybe 300 people or something like that. I think we have 600 people registered, something like that, just for GraphTour today. So it's really, really good to be back. That Graph Connect was a really good one. The main thing that I remember from it is actually on this slide here. This is a gentleman, his name is Volker Pacher. He works for eBay, and specifically with same-day delivery. He worked at a small startup called Shuttle, I think he was based in London. I think the startup was also based in London, which eBay acquired to do their same-day delivery. And this is 14 or 15. And so and this is all based on Neo4j. They used to do it on MySQL, but then they ran into all kinds of performance problems, moved it over to Neo4j. And you can imagine that it's a very graphy problem. You have a bunch of trucks and cars, vehicles driving around. You need to figure out how to get for the most optimal path from point A to point B, considering all the orders that are happening on eBay in real time, right? So they ported it to Neo4j, and he was here to tell that story. And it was a kick-ass presentation, because he started out with going on stage, barely even introducing himself, pulling up a web browser, going to ebay.com, and then ordering a bottle of scotch from some random guy, right? And with address SF Jazz Center. Then he introduced himself, started giving the talk, and then 18 minutes or so later, random dude walks in with a bottle of scotch and hands it to him, right? And that's this picture here. Right? And actually behind the scenes, what I just learned is that he didn't even tell our crew about that. So then we have our crew outside here, like the people who greeted you, and all of a sudden, in comes random dude with a bottle of whiskey saying, I'm going to deliver a bottle of whiskey here. And of course, they had never, what was going on? But then finally, they figured it out and got him in here just in time for the talk. It was a pretty good presentation. Unfortunately, I can't offer you any scotch here today. There's plenty of coffee. There's plenty of stuff like that. But there won't be any dramatic alcohol deliveries throughout this presentation. So I'm going to cover a couple of things today. I'm going to talk about basically the state of the graph union, right? So how are we doing in the world of graphs today? What do I see as the more interesting things going on right now? And then I'm going to shift my focus to the future and talk a little bit about how we see the world of graphs and connected data evolving, what I believe are the high-order bits of the next few years. Before that, though, I'm going to kick off with a story. And that story moves us far away from San Francisco and the Jazz Center into this place. So, shout out. Do you know what city this is?
Bombay.
That's right. Yes, exactly. Mumbai, yes. Bombay or Mumbai. So, this story begins decades ago, well, probably not decades in plural, but a long time ago, when I was a CTO of a young fledgling startup in the enterprise content management space. And we had built our software on the standard stack at the time, which was some kind of presentation layer, web front layer, an application server holding our business logic, and then the standard relational database. But for some reason, something was going wrong in our project, or something was at least very unusual about our project, which was that I was the CTO, had about 20 engineers. Half of them spent the majority of their time just fighting against the relational database. And this is very surprising to me and unusual, because in all my previous projects, the hit points and the magic swords and like all the stuff that I built before I was in my early 20s, the database had been an accelerator. It had been a help. Hey, there's the huge class of problems that are really hairy, like I want to be able to store data, guarantee that it actually gets stored, like when I concurrently access it, maybe store multiple things at the same time, for sure query multiple things at the same time, ideally with some kind of flexible query language. All that kind of stuff is hard. I don't want to do that. Therefore, I'm going to let MySQL do that, or let Oracle do that, right? And that was always working out really well. It'd been an accelerator. But something was holding us back. And it took us a while to figure it out, but it turns out what we now have a very crisp understanding of this, we as an industry, and even a language for it, which is that there was a mismatch between the shape of my data and the abstractions that were exposed by my underlying infrastructure. I had a lot of connected data, as it turns out, and my relational database exposed tables, rows and columns. And you can model connected data in tables. I mean, most people in here probably know how to do that. You put it together, a join table, and foreign keys, and then you start querying that, right? It's doable, but it's really awkward. There's a lot of friction there. It's awkward to do, when you model it and when you store it and when you work with it from a product surface perspective. It's also really non-performant, right? So joins are very powerful, but they're exponentially expensive. I had a lot of that data because we were working with enterprise content management, which is a lot of files that belongs to folders. Those folders belong to other folders in a big nested hierarchy. We also then had a really big, sophisticated security model where we had users that belonged to groups. Those groups belonged to other groups. And then we had security permissions tying together this user group, like hierarchy and network over here, with the content hierarchy, right? That's a big, complex network. Another word for network in mathematics, of course, is graph, that we tried to squeeze into the relational database. And that was when we realized that, hey, something is going wrong here. And that's when we were young enough and naive enough to say, you know what? We need a new type of database. A database that works with this level of connection somehow, right? And we first Googled around or Alta Vista'd around and tried to find one. We uncovered that there were none out there. And that's, again, when we were naive enough to just say, screw it. Let's just build one. How hard can it be? It's just a database, right? Turns out that it was pretty hard. But we started out this collaboration between my company based in Sweden at the time and a university in India, specifically in Powai, in Bombay, called IIT Bombay, where we said, hey, we're going to start to figure out how to model connected data and represent that in a database, right? And I remember still the kickoff week. On that flight to Bombay, we literally grabbed a napkin, literally like one of those flight napkins, and we started sketching out what we now know as the property graph model. And I would love if we still had that napkin. This is not that. This is a digital recreated version, to the best of my recollection. But you can see this here, what's emerging here. It's something that can store entities, right? We now call them nodes. And it's how they are connected, right? Nodes and relationships. And so you can imagine that you can store maybe people, right? The nodes are people, and how they are related are relationships, right? And then we have properties to describe the primitive data, right? Circles we call nodes, the arrows between them we call relationships, and the key value pairs we call properties. With this very, very simple model, just these three concepts, you can model everything, right? And we saw that there was a really good fit for some class of problems, not all classes of problems. If you have maybe a payroll system, right? You have first name, last name, title, salary. It's a very tabular thing. If you would ask someone who was a domain expert in that, hey, talk about your domain, draw it on a whiteboard, they would probably draw a table, right? That's a great clue that is a great fit for a relational database. But there was a lot of data and a lot of applications out there where the value was in not just in the core data, but how it was related. And with this model, all of a sudden, you can very easily evolve it, right? So now we have some kind of a social network here, right? But what if we want to start adding things? Hey, maybe we want to add a marketplace to our social network, right? Then we can just add new types of nodes. We can add new types of relationships. This new type of node represents something that I want to sell, and I have a new type of relationship called sells, right? You don't need to create a new table. You don't need to update any schemas. You can just easily evolve your model. So it ended up being this very powerful, flexible model for us to work with. It was powerful when we can do this with, what is this, 7 nodes? But even more powerful if we could wrap it in an infrastructure when we can do this with 1 million nodes, or 1 billion nodes, or 10 billion nodes, right? Then that starts becoming really, really powerful. So that was the original vision way back in the days when dinosaurs ruled the earth and people used Alta Vista to find things on this whole crazy thing called the web. Fast forward to today, and that napkin is starting to have some real impact on the world. So a couple of examples of that inspires me a lot about what we do in the graph space. How many in here remembers the Panama Papers? Probably 50%. So this was basically the biggest news story of 2016 until Brexit happened and then Trump happened. So yeah, 2016. And it was basically this massive data journalism work where a big collaboration of investigative journalists had gotten this data leak from a tax firm that was specializing in foreign tax accounts. So tax accounts in tax havens. So that could be used for legal tax planning purposes or for illegal tax evasion. And they started looking into this. And this was all about individuals that were connected to the bank accounts, and those bank accounts were in jurisdictions, individuals who were officers of companies. Those companies had bank accounts somewhere. So a lot of connections and relationships in all that. Ultimately, several prime ministers had to resign. The prime minister of Iceland, the prime minister of Pakistan had to resign due to findings in this. Putin was in there. Queen Elizabeth was in there. It had a really, really big impact. And this was all data that was stored in Neo4j. And several of those data journalists said that without Neo4j, we would not have been able to find any of this data, which I thought was pretty amazing. Second example is NASA. And there's a great story here, which you can find online, which I'm not going to go into too much detail. But basically, they were using a knowledge graph backed by Neo4j in Project Orion. And Project Orion is the mission to Mars, where they are on the record now, NASA saying that thanks to that knowledge graph in Neo4j, humanity is going to get to Mars 2 years earlier. Right? They saved 2 years of time in the mission to Mars, thanks to findings that they found in that knowledge graph, which I thought was pretty amazing. And then maybe my most favorite part of these stories is there's at least a dozen projects right now where people use Neo4j to help find the cure for cancer. And if there's a few things that unify mankind. One is we're all going to compete with Amazon one day. That's one thing. But another more unfortunate one is that I think most people are just 1 or 2 hops away from someone who's been impacted by cancer. It turns out that in that field, there's a lot of information, and it's very much a data-driven play at this point, finding the cure for cancer. But a lot of that data is trapped in silos. And what people are using Neo4j for is to extract that data out of silos so that you can track cause and effect across multiple types of data. So the butterfly effect, hey, it turns out that this particular person reacted in a certain way, and you can track that all the way down through demographics, through the particular samples that were used, the particular treatments that were being using. And all that data was typically stored in silos before. So those are a couple of stories where we've seen real impact of graph databases on the world today. A more local example is a little company that all of you have heard of called Adobe, which has a product or it's a community platform called Behance. And Behance is a meeting place or a community forum or a social network for creative professionals. So if you're a user of Adobe products, you can go onto Behance and you can publish your material. And at the core of that platform is an activity feed. Right? So you can follow other creative professionals and follow their projects. And then when you log on, you're going to get updates on what they've done. Right? And you can imagine the domain model is something you have users and artists and galleries, and you want to be able to track that. The Behance team tried to do this with several generations of non-relational databases, ranging all the way back from 2011. And the first 2 generations had all kinds of problems where they had to do updates in batch. They couldn't do real-time updates. It consumed a lot of data. It had to, because they had to denormalize and duplicate out so much. And it just was very, very operationally heavy. And there was a talk at Graph Connect, I want to say a year and a half ago, by a gentleman called David Fox from the Behance team, where he walks through that entire journey. And one of the punchlines is that they started out in 2011 with 125 servers of Mongo, which they then moved to 48 servers of Cassandra. And that is now running on 3 servers, a cluster of 3 servers of Neo4j with more functionality, higher throughput, lower latency. Right? Pretty extraordinary. So taking a step back from these particular examples, in the world today, what do we see people use graph databases for? So fundamentally, what graph databases are, much like the relational database, it's a fundamentally very horizontal product, right? And probably the purest way of thinking about when to apply graph databases comes down to very fundamental things about the nature of data. Like if you have a lot of connected data, then that fits well with graph databases. The question then is, what are the business level use cases where you have connected data? And we've identified 6, and these 6 probably represent 60–70% of our business, something like that. So there's a lot of interesting things that people do outside of these 6 use cases, but this is the majority. The first one is real-time recommendations. So you can imagine that if you're a big retailer, you've stored your purchase history in probably a mainframe database, probably DB2, but could be Oracle or something like that. And you can just think about that data, and it's something like customer ID, time, date and time, bought this product for that $1, right? Extremely tabular, right? And a great fit for a relational database. But if you take exactly that same data and you look at that along relationships, then all of a sudden you can see that, hey, there's Emil, and Emil has bought these 3 products, right? So there's a relationship between me and those 3 products. And hey, there's Lance over there. He makes geeky jokes about multi-user dungeons. They probably share the same interest. And it turns out that Lance has also bought those 3 products. Let's take the 4th product that Lance has bought that Emil hasn't bought, and then recommend that to him. Collaborative filtering, right? Just that tiny little example is 12 hops inside of that data structure. Something that you, in reality, at least not in real time, you can't do that with a relational database. So very popular use case. Fraud detection, there's a lot of really good fraud detection software out there. What most, if not, like I would say probably none of them, can capture is what's called fraud rings, where you have a lot of transactions that are individually deemed okay. They're within that band of what's normal. They're not outliers and anomalies for you to investigate. They're all individually okay, but they're connected in ways that are not okay, that are fraudulent, a fraud ring, for example. In order to detect that, you need to be able to work with connected data. Network and IT operations is fundamentally a very connections-oriented thing. If you're a big telco, your entire business is running networks, right? Networks, graphs, same thing. Equivalent on the enterprise side, if you run big data centers and you want to be able to track, hey, if I have a breach over here, how can that cascade across all my data centers, right? That's all about how my equipment is connected. Master data management, very broad bucket, breaks down into several subparts. Customer 360, how are my customers connected to both external and internal system, external like social media and whatnot, internal like all my internal system. How are my customers connected, customer 360. We also see a lot of data lineage right? So tracking data over time and how that is evolving, who's touching that data, audit logs, things like that. Knowledge graphs, how do you store information in a very graphy way so that you can access that both by humans. For example, when you search on Google and you search for SF Jazz Center, you're going to find the normal hits, like the normal search results, but you're probably also going to see a panel right on the right-hand side. And that's going to tell you what the SF Jazz Center actually is. That's using a knowledge graph. It's used directly by you as a human being. Or knowledge graph used by machine learning, and we'll talk a little bit more about that later. And then the sixth and final one is identity and access management, which is a little bit related to that original thing that I talked about, where you have a lot of people, they belong to groups, which of all our content and assets inside our big bank or our big enterprise, which assets does that particular individual have access to is a connected data problem. So inside the enterprise, this represents, again, probably 2/3, something like that, of all the deployments of graph databases that we see today. So taking a little bit more of a step back, I want to tell you another quick story which cracked me up when it happened. So just around the time when I was last here in SF Jazz Center, 2014, Forrester, which is one of the big research firms covering the IT industry, they published a report when they had surveyed their enterprise clients about all kinds of data usage. And that report said that their estimation was that over the next 3 years, so until 2017, 25%, in fact, over 25% of enterprises will be using graph databases. And I remember when they released that, I am pretty optimistic and pretty bullish on the rise of graph databases, as you can imagine. But I just looked at that and said, like, that's crazy. That's just such a staggering number. But it turns out they weren't all that crazy. They were pretty data-driven about it. There's a site that some of you may have heard of called DB Engines, and it tracks all these new database products, right? It used to be in the mid-90s when I grew up as a professional developer that there was like 4 or 5 databases to choose from. And all of them, they were the same product, right? It was basically a vendor choice, like Microsoft or Oracle or IBM, right? Now, there's an explosion of new types of databases, as we all know. And so DB engines are tracking all of them. And so that's interesting. Even more interesting is that they track it by category. And if you look at the popularity of categories, and I should, when I say popularity, it's like number of tweets, number of jobs, stuff like that. Then graph databases have actually been the fastest growing category in all of data. Since when? Since early 2014. It's probably not visible here, but this is, you can see it here. I can see it. So this is when graph databases started taking off and really the rise in popularity, just around the time when Forrester published that quote. So end of 2017, they stretched their intellectually honesty muscles and said, hey, let's actually look into this and see where we ended up. So they surveyed over 2,200 enterprises about their usage of graph databases. It turns out that in 2017, actually over 50% of enterprises were using graph databases, which was pretty mind-blowing to me. So that number that even I thought was pretty much a stretch number, it seemed a little bit crazy. We even over-exceeded on that. So I thought that was pretty stark. A couple of months ago, sticking with the analyst theme, Gartner published their top 10 data and analytics trends for 2019. And trend number 5 is basically 9 trends that have the word AI and machine learning in them. And then one trend, which is graphs. And they talk about how graph databases will grow at 100% annually for the next several years. And it's going to grow due to the need to ask complex questions across complex data, which is not always practical or even possible at scale using SQL queries. Even more amazing, I think, is that we never looked at this as we want to be the one company doing this. One of the early decisions was that we didn't patent any of our software because I always felt like hey, I want other vendors to implement graph databases, because ultimately I think this is such a valuable thing, and helping the world to make sense of data and figure out cause and effect through relationships seems important. And why should we be the only one doing this, right? And so we've tried to be very focused around preaching the benefits of graph databases. Then, of course, I'm not going to hate on you if you use Neo4j. That's fine, right? But to me, like the even more important thing is that you take that relationship view of data, if that's appropriate. And what's been amazing to see is this massive vendor landscape that have grown up around property graphs. This was published a few months ago by a consulting firm, a graph database consulting firm called GraphAware. And they just made, there's several more of them, but I thought this one was pretty good. And I remember when it came out, like I think in February, I just looked at it. There's like so many logos out there, right? And you think back to that napkin moment until this, pretty amazing. Sticking with that theme, Neo4j today has this really, really significant ecosystem. A couple of data points for that. There's over 20 million downloads of Neo4j to date. This is one of over 400 events that are going to happen this year, and that has been true for several years consistently. That's almost 2 events per working day, right? And so you can be, if you're interested in Neo4j, you can be pretty comforted that there's going to be a community of people almost wherever you are, right? For sure here in Silicon Valley, but that's kind of obvious, and I think we're probably a little bit used to whichever new technology we want to tap into, there's always going to be some meetup group or a local community. But this is true in most places of the world today for Neo4j. Over 50,000 trained and or certified developers on Neo4j, and I already mentioned the meetup groups. I think this is a really important part of building an ecosystem and a movement around graph databases. So what do we see? So we had the Forrester Analysis of 50%, over 50%. Today, it's almost 80 of the Fortune 100 are piloting or adopted already Neo4j, which I thought was pretty cool. Even stronger than that, if you look into some of the top verticals of the world, 20 of the 25 biggest banks, 20 of the 20 biggest banks in North America. If you've used an ATM today, you've used Neo4j. A couple of other examples, 3 of the top 5 logistics firms, 3 of the top 5 airlines, 7 of the top 10 retailers are all using Neo4j. Did anyone fly here today? Hands raised. A few people. 99% of all the flight ticket calculations in the world are done using Neo4j. If you've ever stayed at a Marriott or a Ritz-Carlton, like that room was booked using Neo4j. It's pretty widely used today across a very wide range of industries. And these are some examples of some of the biggest firms in the world, right? We are very, very excited about big companies using Neo4j, quite obviously. We're also really excited about startups, and that, obviously we're a startup ourselves, and of course here in the Valley there's a lot of startups, quite obviously. And we have this startup program that I'll talk about a little bit in a moment, which we launched a few years ago, which today has over 2,000 members, over 700 active members in that startup program, and a total of over 2,000, which I thought was pretty astounding. And that startup program is basically that you get free access to Neo4j Enterprise, right? So there's a community edition, and then there's an enterprise edition with all kinds of goodies in it. And we just recently actually announced at one of the GraphTours a couple of months ago, we just recently expanded that program. So now if you're up to 50 employees who have less than 3 million in revenue, you can enroll in this program, and you're going to get complete access to Neo4j Enterprise Edition, which is the database, and then Neo4j Bloom. Hands raised. Does anyone know what Neo4j Bloom is? A few people. So Neo4j Bloom is a graph visualization tool. And one of the things that has always amazed me about the graph model is that I can't tell you how many times I've been in meetings when people tell me that, hey, one of the biggest benefits of using this, someone technical says, is that I can take the data model and I can show it to my boss and my boss's boss. In fact, I can even show it to the business people, and they understand it, right? Because they see that, hey, that's my supply chain over there, or hey, that's my shopping cart data, that kind of stuff, right? And they can relate to it, which you rarely can do in a relational database. Sometimes you can if you have that payroll, maybe, but very rarely, because you typically split up that data, decompose it into various tables using third normal form and all that kind of stuff. And so what Bloom gives you an opportunity to do, this is a tool that is optimized for end users that are not developers or data scientists, right? So we have a query language to Neo4j called Cypher, which is now widely adopted across other graph database vendors and is rapidly becoming a standard. And that query language is fantastic and really easy to work with if you're a data scientist or if you're a developer, right? But for, I say this lovingly because I'm an ex-developer, I tend to think of developers and human beings, right, as separate Venn diagrams. And so for human beings who do not want to type SQL or Cypher queries, then Bloom gives you a way to just use it, kind of like Google. You search for it. I'm sure you saw some of that. And then you can just live explore the data. And this is all available if you're a startup, again, less than 50 employees, 3 million in revenue. It's all available for free. If you're above that, you can obviously still use Bloom under an enterprise subscription. So that's a little bit kind of how I look at the state of the union today, where graph databases are being used today, and some of the really exciting impact stories like NASA and Panama Papers and Cure for Cancer. Now, switching gears a little bit, and let's talk about where we believe graphs are going to go in the future. And of course, one of the key areas of data right now, in fact, probably one of the key areas of technology, is the world of AI, right? And so the question then is, how do graphs and AI interplay? And we spend a lot of time thinking about this. There's a lot of early cues about that there's a very intimate connection, no pun intended, between AI and graphs. One example of this, a few years ago, just on one of my social media, I think on LinkedIn, I saw a picture which I thought was a good taxonomy over the various subdisciplines of artificial intelligence, of which there are many, as you know. And I thought that was a really good just taxonomy, generally speaking. But of course, what struck me was that the way that they chose to visualize these various subdisciplines were with graphs. And this was not us or someone in the graph space. This is just a generic AI observer. And just they chose to visualize all this as graphs. So there's clearly something there with how things are related and artificial intelligence. And as you think a little bit more about it, I think that the role of graphs in AI is to provide context. It's to provide meaning through connections, which we call context. I think that is the role, broadly speaking, of graphs in AI. So let's talk a little bit about what context means to me, right? So this is an example. You can think of me as an individual and data that is attached to me directly. Imagine that, I'm a document in a document database, right? Then first name would be Emil, last name would be Eifrem, age would be 40? 40. Yes, 40. Yes, 40. Yes, 40. And gender would be male. That's like information that describes me. Now you're starting to get to know me. You didn't know that my age was 40, and maybe I didn't even know that my age was 40. So you're starting to get to know me a little bit better, right? But if I tell you how I relate to the world, right? So this is me, and I'm the father of 3 young girls. I work at this amazing company called Neo4j. I'm married to Madeline. I play the piano. Which is not true. I play, because of the first little note over there, I play Twinkle, Twinkle, Little Star on the piano. That's what I do. But I'm actually a classically trained pianist. I watched a TV from the 1960s. I don't know what that. This is supposed to show the Matrix movie, but I think something went wrong in the iconography. I was born in Sweden, and I drive a Tesla. Yay! That's not true. I don't drive a Tesla. I'm not that cool. It's fake news. I do drive a Volvo. Yeah, go Sweden. Also, because Volvo, even more importantly, is a happy customer doing really, really amazing things with Neo4j. So I thought I'd retribute and buy one of their cars. So all of this is what gives me color, right? I think now you understand even more, arguably, for sure more, arguably even more, than that core data that was just attached to me, first name Emil, last name Eifrem, right? And that's all how you relate to the world. I mentioned that I have 3 daughters. One of them is that daughter, the really young daughter. And it's pretty amazing to see how she's growing up, how she's learning about the world, right? I think that when you're born, you learn, like you know a very few amount of concepts. You know mom, right? Temperature, boobs, right? Like the essential stuff, right? And then as she learns new things, every new thing that she understands, she understands that by relating it to previously known concepts, those 3 or 4 concepts that she was born with, right? So dad, he's kind of like mom, right? And I think actually what knowledge is you take something, an unknown concept, and you understand it by relating it to previously known concepts. And I think that how those things relate and how they connect is very fundamental through learning. And this is what is expressed through knowledge graphs. I spent at the GraphTour in San Francisco last year. I don't know if anyone was here. I spent a lot of time talking about knowledge graphs. I'm not going to talk about that today, but we have some really amazing deployments of Neo4j for knowledge graph use cases, including some of the logos that you see up here. So that's one kind of fundamental part of graphs and AI. What I'll spend a little bit more time on today is machine learning. I've been told that I should not use the phrase ML too much because it sounds like my name. Because my name is Emil, and I'm not quite that egotistical. I haven't turned into Larry yet, so I don't go on stage and just talk about Emil. So I'll try to say machine learning rather than ML. And I don't know, so how many data scientists do we have here? Probably 25% or something like that. So this probably won't be news to, well, it won't be news to data scientists. For those of you who aren't as close to that world, what kind of the classic machine learning pipeline looks like today at a 10,000 feet level is something like this, right? So the goal is that you want to train a model so that when you throw that model at the real world, it's going to make predictions, hopefully accurate predictions. That's kind of the goal, right? And we train that model with data. And so kind of step 1 is identify what are the data sources that we're going to use to train our model. And it's one of those like crap in, crap out. So it better be good data, right? Otherwise, it's just going to predict based on that data, which won't be good, right? And so you choose that. You take that data out of those data sources, and you put it in what's in that world is called features, right? And so you use those features to train the model. And if most of us are probably database people here, so you can think of those features basically as rows in a relational database, right? It's very, very simple. And then you throw that on the models, you train those models, and ultimately you can get to something that can hopefully predict things about the real world. So that's great. Now, what's interesting about this is that, okay, so we're training this system on something that we want to resemble the real world as much as possible. However, what I think we all know here in this room is that the real world actually doesn't look like this, right? In fact, the real world looks more like this. Like we have these data points, and they are related to one another, and they change, and they evolve. And it's all about like how those data points actually fit together, right? And the question then is, if we train those models based on the simplified view of the world, will they be able to do good predictions? Yeah, sometimes. And the interesting question then is, if we could train them based on a more accurate version of what the world looks like, would we be able to make even better predictions? And it turns out that there's been a lot of research done in this area. Probably the favorite person, my favorite person in terms of research, and specifically this topic, is a guy called Stephen Colbert. This guy. No, not that guy. I don't think he's great. I'm not sure if he's like a world-class machine learning expert. But this guy over here is a professor from UCSD called Professor James Fowler. And this is him at the Colbert Show. And then after the Colbert Show, he went to another show, a much more important show, called Graph Connect. And he was actually our first keynote speaker at the first ever Graph Connect, the one that even predated the one here in the SF Jazz Center in 2012. And he was talking about this book that he wrote called Connected, which is that was a name that drew our attention. Where he's actually a social scientist. I mean, he's very, very deep on geekery too, but he actually applies it in the social sciences. He specifically was looking at the time at voter turnout, election turnout data, right? How can I predict whether someone is going to turn out for an election? And also smokers. Is this person going to be a smoker or a non-smoker? And he learned something very, very counterintuitive, which is expressed here, which is basically that if you know the friends and friends of an individual, you'll be able to statistically significantly better predict whether they will turn out for that election or whether they are a smoker or a non-smoker. So imagine kind of two universes. One universe, you know everything about me. You know my medical history, you know my lifestyle, you know my educational background, my income, you know everything about me. And you're going to try to predict whether I'm a smoker, let's say. Or, that's one universe. Another universe, you know nothing about me. Gender, like everything is unknown about me, but you know my first level out graph. It turns out, counterintuitively, that it is much easier to predict whether I'm a smoker or not if you know my graph than if you know everything about me. Right? And that's a pretty staggering conclusion, I think. And it was even deeper than that. I think he mentioned it here. Yeah, so he didn't even have to know the direct graph, one hop out, but he was sufficient just with 2 hops out even, right? And so that's a pretty staggering conclusion. And if that is true, then, and we're training all our machine learning systems to kind of ignore, we're not training them to ignore, we're training them ignoring how things fit together, ignoring relationships. It seems like we're missing a big component of what could potentially provide better predictive abilities. So in a word, what we want to do is be able to move from this type of view into this type of view, right? Which will then ultimately lead to better predictions. So we want to move from normal features, you can think of them again as rows in a relational database, to what's called connected features. And this, now the really good news about this is that this used to be theory back in 2012, and probably even in a few years ago it used to be theory. Today, there's a lot of people who have actually put this in production and are applying this. And there are several talks later today that are starting to walk you through how to put this in production in a real-world scenario even today. Because the really good news here is that this is not, you don't need any new systems for this. You need to add a graph database and use that to feed into your machine learning pipeline. But everything else in your normal machine learning is the same, right? So we see this as an important pillar of the future of how graphs and AI interplay. In fact, we see it as one of 3. And the first one we talked about a lot last year, and I just mentioned very high level now, which is knowledge graphs. And the second one here is, again, using connected features to improve accuracy in your machine learning. And the third one, graph native learning, is actually a part of deep learning, where you use graph-based models that can, it's called graph neural networks, that can both consume data as a graph, process that data, and then output that data as a graph. So it's native graph all a long way. And it's one of the hottest areas of research in machine learning right now. in fact, in AI right now. And some of the smartest teams in the world, including Google's DeepMind team, is spending a lot of time focused on graph-native learning. So this is what I believe is going to be driving a lot of graph database uses over the next several years. Obviously, AI and machine learning is a trend that is bigger than probably anything going on in technology today. And I think that graphs have a central role to play in all this. So that concludes my intro to this talk. Hopefully that was a good overview that gave you a sense of where the industry is today and where we see it as going over the next few years. I'll conclude with one thing. One of my favorite analogies for thinking about the graph model is actually inspired by what I believe is the best database in the universe. The best database in the universe, which of course there's a couple of hundred of them here in this room, which is the human brain, right? Which ultimately, fundamentally works with neurons connected to other neurons through synapses, which is exactly the graph model. We call them nodes and relationships, but it's exactly the same. And the central part of that is the relationships. That is what sets us apart. What's the difference between a document database and a graph database? Well, our nodes are exactly like their documents, like key value pairs, right? But it's the relationships. That is fundamentally what sets us all apart. And one of the things that I always conclude with when I give my talks at Graph Connect is that I want all of you here at this conference to behave like graph people today. And Lance alluded to this in the opening of the conference, which is strike up conversations. Shake 5 hands, shake 10 hands if you want to go really nuts. But ultimately, connect with people, because fundamentally, that's just going to make it a much, much better and more fun conference for us and for you. Thank you, everyone, for paying attention, and have a fantastic day. Thank you.